Okay, so as I said, this video is about the one about cystic fibrosis. Now, cystic fibrosis is one type of genetic disease. There are many types of disease. Now, how do you spell fibrosis? That's one question. I'm a horrible speller. What? R-O-S-I-S. Thank you. Cystic fibrosis is a genetic disease that is what passed down by a recessive gene. Most genetic disease, thankfully, are passed down by recessive gene. There are some examples, and you'll learn about one. Okay, and now cystic fibrosis, the gene that talks about that is okay. So because cystic fibrosis, people who have cystic fibrosis will have an abnormal production of mucus. And actually, if you think about mucus, you think it's sticky and whatever. It keeps, for example, most of your surface, especially your lungs, moist. Your lungs can do gas exchange because it is a moist surface area. So imagine that you have an abnormal production of mucus. So either you can't do gas exchange properly, or you have way too much mucus and there are problems. Okay. It is a genetic disorder, and so thankfully it's recessive. Now, the textbook as well as IB notation that they expect you to know is this. If you have a capital F stands for the allele that codes for healthy production. Healthy production of mucus. Codes for healthy production of mucus, so you don't have cystic fibrosis. If you have a small f, then you code for cystic fibrosis, CF right now. You guys follow? Now, one thing in the textbook that they mentioned as well as a good tip. On the exam, you're not, because all your exams are going to be scanned and your paper is going to be e-marked by someone far, far away. Make sure when you do these questions, keep to the notation that the IB set to, as well as make sure if you have to make up a letter or make a form of the letter, that is easy to tell the capital from the small case. Imagine if it is like a big C and a small c. Well, how would your examiner know if your big C and small c doesn't look that much difference? Does it make sense? So it is smart just to make sure that you're not losing mark when you don't need to, okay? So in this case, let's just say a mom and dad, okay? Well, that's how it all usually works anyways. Mom and dad. So both person can be healthy, okay? But they might carry the allele that codes for cystic fibrosis. So I'm gonna make it fun, so just make sure that they're both of them contain a big F and a small f. If you have a big letter and a small letter, what is the term for that?
Heterozygous.
Heterozygous. Okay, you have a big letter and a small letter. So these are both heterozygous. Now, heterozygous, because you're talking about a genetic disease that is recessive, so these people, they're heterozygous, even though they're healthy, but they still carry the allele, they still carry the gene for the disease. So you call these people carriers. Does it make sense? They carry the disease, even though they're healthy themselves. So in this case, their phenotype, that's what you can see on the outside. So it doesn't matter. Oops. But on terms of genetics, which two letters they have, that's the genotype. They carry the allele. Good? Now, forming a Punnett square. If you learned how to do this before, that's great. If you haven't learned how to do it before, I will kind of make sure you please do it the format that I show you. Punnett square. Dad's on top, mom on the side. And for each of these columns, you pick one letter. So your dad has two letters, a big F and a small f. So the big F go here and the small f go here. Good so far? Mom's on the side, so one letter, big F here, small f here. Good? Now, to fill in each box, you just take, for this box, you take one from your dad here, one from your mom here, so it's two big F's. To fill in this box here, your dad gives you a big F, your mom gives you a small f. Good? Same thing here, small f, big F, small f, small f. Questions? Now, in this case, what do you have here? You have one. Now, I'm going to look at the genotype of the offspring first. Genotype of the offsprings. Genotype of the offsprings, you have the following ratio. I know the video, they only talk about the ratio of the phenotype, but I want you to make sure you know how to do both. Okay? For the genotype ratio, you have one big F, one big F, big F. If you have two letters of the same case, what is that? Homozygous. Homozygous. That's what I'm talking about. Homozygous. You have two potential cases of a big F and a small f. So you have one homozygous dominant. Okay? Might not be the most politically correct, but I don't have that much space. So, two homodominant. I have one homodominant. You have two hetero. Hetero is just hetero. There's no recessive dominant. You have one homozygous recessive. Do you guys follow so far? So that is the genotype ratio. The phenotype ratio, kind of like, are these kids going to be healthy or not? Or healthy or have cystic fibrosis? In this case, you have the phenotype. Now, because cystic fibrosis, as I said, it is a recessive trait, these guys here, these two potential cases, two potential kids, can have, even though they have the allele for CF, they won't have the disease manifest. They will carry the gene. So in this case, you have three healthy, even though two of them are carriers, and one kid with a CF. Do you guys follow so far? Questions? Now keep in mind, all these things are like chances. When we're talking about genetics, we're always talking about chances. What's the chance of this? What's the chance of that? Okay. So in this case, you will also have to be expected to how to figure out the probability. Okay. So how many cases per 4, that kind of thing, and then you round it to a percentage. Questions? Any questions? That's a basic cross.